What I'm not going to do is to give you a review on GLUT1. I'm going to give you an update on GLUT1, and that actually means that I have to focus and give you some spotlights of what's going on. Nevertheless, for someone who has never heard about this condition, here is GLUT1 deficiency in a 30-second nutshell. Your brain needs glucose for energy. The glucose arrives from the bloodstream and is transported into the brain, and for that you need a transporter called GLUT1. If this transporter is broken, you have GLUT1 deficiency, an energy crisis in brain, and that causes epilepsy, developmental delay, and a movement disorder. Now you can effectively treat that by means of a ketogenic diet because you can refuel the brain by ketones. So you offer the ketogenic diet, ketones can be used by the brain for energy, and these children do better. And that's basically the review of GLUT1 deficiency. So I'll move on to the update. And you've seen that from Helen, from her introductory speech. You can see that you enter the search ketogenic diet, and you can see that really it's been going up over the past years. And the same holds true for GLUT1 deficiency, and I'm pretty convinced that this has to do with our global dietary meetings, as we have with the 4th meeting in Liverpool. Now, the first focus is on the transporter itself, and there's something very exciting to share with you. The glucose transporter has been tried for decades. Scientists have tried to model the structure of the glucose transporter, and they failed. And now for the first time, and that's been published in Nature in June this year, they have managed to crystallize the transporter. They used 2 tricks. They introduced 2 mutations. One mutation sort of deleted the glycosylation site, so a lot of variants were deleted, and then they introduced the second mutation which locked the GLUT1 in an inward-facing conformation. So you just have one conformation, and then they were able to crystallize it, and that's what they found. They found that there's a blue C domain and a green N domain, and these are sort of linked together by an intracellular helical bundle, ECH, that connects these 2 domains and forms a sort of latch. Now, why is that important? Because this is the basis for a working model of how these transporter transports glucose. As you can see here, it's outward open, so glucose gets in, gets transported through the transporter, and then it'll be released into the cell, and then this is recycled, and back it starts for new glucose. So this goes this way, can go the other way too, and this is the working model. Now, why is that important for GLUT1 deficiency? Basically because now it allows accurate mapping and mechanistic interpretation of all the GLUT1 mutations we find in the literature. And they actually here as the magenta dots. And basically there are 3 clusters. One cluster mutation affects the substrate binding, the glucose binding to the transporter. The second cluster of mutations affects the interface domains, sort of these 2 domains working together, and the latch working together, and then the cluster 3 mutations, they affect glucose transport because there are interactions between these 2 domains. And let me just point out how that works. If you magnify the interaction of the blue and the green domain, you can see that there are certain amino acids involved. One of them is asparagine 34. And asparagine 34 has been described as a hotspot for GLUT1 deficiency for patients described. And what you can see here is that you have hydrogen bonds, and if they are affected because this amino acid residue is affected, you won't have glucose transport. So in these 4 patients, we can actually tell the patient, here's your problem. These 2 domains don't interact because of missing hydrogen bonds. And I think there are much more to come if you interpret the the mutations we have to date. Carry on to symptoms and diagnosis. I'm sure you know what movie I'm referring to. It's an old movie, and I now feel that GLUT1 deficiency is beginning to be an old story because it's 23 years ago that it was started with 2 patients, then we had 10 patients. In 2007, we reported 84 patients, and now this is a sophisticated estimate. We have approximately 300 patients. Life was easy in the beginning. We just thought there is sort of 3 clinical symptoms, that is intractable epilepsy, a movement disorder, and the developmental delay. And then here comes Ingrid Schäfer and her team from Australia and told us that 1 out of 10 children with early onset absence epilepsy as the only symptom might have GLUT1 deficiency, and they can actually benefit from a ketogenic diet. So here we had a completely new form of epilepsy affiliated with GLUT1. Then the same group showed us that in myoclonic astatic epilepsy, Dose syndrome, about 5% of patients have GLUT1 mutations, and even in idiopathic generalized epilepsy, there's about 1% of patients that do, oh sorry, was it 1 out of 1,000? 1 out of 1,000, right? No, 1 out of 100, I was right, who carries a GLUT1 mutation. So these patients will benefit from a ketogenic diet. On the field of the movement disorder, we learned that there is an adult disease with a dystonia called PED. I'll explain that to you later, which has to do with GLUT1, and also that these patients have paroxysmal, sudden, non-epileptic events, attacks that we didn't know about previously. And then we have 2 novel conditions. One, a very complicated hemolytic anemia, stomatin deficient cryohydrocytosis, very rare but affiliated or associated with GLUT1, and even alternating hemiplegia, a pediatric neurological condition. In the beginning we thought we just give them a classical ketogenic diet, easy. Up comes Eric Kossoff with the modified Atkins diet, and now we have to think twice whether we should offer these children the modified Atkins diet, or as Elizabeth Thiele and Heidi Pfeiffer showed us the low glycemic index diet, or Triheptanoin, which will be a novel compound I'm talking about at the end of my talk. So you see a lot of things going on. Now this is the classical form of GLUT1 deficiency. It's been named, you find it under OMIM 606777, and basically you have low CSF glucose in the lumbar puncture, you have an impaired glucose uptake assay, and you have mutations in the GLUT1 gene, and this is how you do your diagnosis. In terms of the symptoms, I told you have epilepsy, you have the movement disorder, and you have the developmental delay, and in the classical phenotype, patients show all 3 symptoms, but we have now learned that there are patients that just have epilepsy, just the movement disorder, or just the impairment, and there are sort of interfaces between these, and they all have GLUT1 deficiency. So what we need is a clinical classification of those. This is actually the second GLUT1 deficiency type 2 that you'll find when you enter OMIM, and this is 612126, and it's basically an adult disease. So that's something very new we learned. It has to do with this dystonia, which is a movement disorder, and it's paroxysmal, meaning sudden, and exercise or exertion induced. It might or not be associated with epilepsy, and it might or not be associated with a hemolytic anemia. Now, this is a man who is well known to adult neurologists who has this PED. There are several causes for this PED, but one of the causes is GLUT1. And if I just can have the video, please. This man was asked to do some exercise and then simply rest on his bed, and you can see that he can't do that. He's got these sudden paroxysmal jerks and funny movements, and that's what you call PED, paroxysmal exertion-induced dystonia. And a lot of these patients are misdiagnosed as psychiatric patients, whereas they have a real neurological problem. And in some of them, GLUT1 deficiency is their problem, and they will respond to a ketogenic diet. Now, what about this hemolytic anemia? It's got a complicated name, hereditary, meaning autosomal dominant, stomatin deficient cryohydrocytosis. What actually happens there? There are only a few patients described in the world. They have a different morphology of the erythrocyte. This is a normal erythrocyte, and this is a stomatocyte. So that happens to them, and that's why these erythrocytes, these stomatocytes, get busted, and that's the hemolysis, and that's why they get anemia. And we know that this is caused by several genes, this gene, and now what's new is that the GLUT1 gene also may cause that, and we don't really have a very good explanation for it. We know that stomatin is important for membranes and for degradation of membrane proteins, and we know that it is closely associated to the GLUT1 transporter. So maybe that if you have a defect GLUT1 transporter, this somehow affects stomatin in these patients. Now, this doesn't explain why the majority of GLUT1 patients do not have hemolytic anemia, and it's an open question. We just don't know today what's going on there. but it's something new to share with you. Carry on for treatment. It is really encouraging. This is a survey done in August this year, so just 2 months ago. How do you keto? A survey of 56 ketogenic centers in America. And what is encouraging is the ketogenic diets are accepted as first choice treatment for GLUT1 deficiency. You can see that in 86% of these centers, it is considered first or second line therapy. What's a bit disappointing is that all the other entities we've been talking about on this meeting, like Dravet, West syndrome, and Dose syndrome, is basically considered third and fourth line treatment, and I don't think we would all agree with that, but this is a survey, and maybe this will move into that category eventually. The question is, which diet shall we use in GLUT1 deficiency? Well, we do know that the classical ketogenic diet, 3-to-1, 4-to-1, works, and it works fine. But it is really necessary. We know that there's a modified Atkins diet, and maybe this is a good option, even for patients with GLUT1 deficiency syndrome. We have no experience worldwide with the low glycemic index treatments, and Heidi Pfeiffer in her talk the day before, she mentioned that it's not really indicated in this condition, and I would agree up to now, because the question is, do they provide enough energy for the developing brain? And obviously in a very, very low, moderate ketogenic diet, like the low glycemic index treatments, where you hardly get any ketosis, you might not get enough fuel to refuel the brain and treat the energy crisis. So what about the modified Atkins diet? And we all like it, and we like Eric and his work. But basically the data on GLUT1 deficiency and the modified Atkins diet is very poor. There are 11 patients out there, and there's just been another paper coming out with, I think, 2 or 3 more patients. But this is not enough to support that it really works. So I'm very confident that the modified Atkins diet, especially in adolescents, is a good option for GLUT1 deficiency, but we need to prove it. So whenever you have a patient on a modified Atkins diet, you haven't published it, please do. And please do publish it, even if the results are not that nice, because we need to know whether this really is a good option or not. We believe it is, we all behave like it, but we don't really have the evidence in the literature yet. The key question really is, does the degree of ketosis matter? And I want to just carry on to the problems we have. The changing phase of GLUT1 is that, as I told you in the beginning, we just thought, okay, we have seizure control, we have to look for development and the movement disorder, and eventually these children will grow into adulthood, things will get better, it's not a neurodegenerative disease, we'll be quite happy with that. Then we had the novel ketogenic diets, and we said, okay, maybe we can ease on the ketogenic diets when they grow older, then maybe the modified Atkins diet in adolescence is a good idea, and maybe the low glycemic index diet eventually will be an option in adults. The real problem is that now, as our children grow older, we realize that puberty is a really, really sensible phase in their life, and that they run in all sorts of problems. They have more paroxysmal events, and they increase with age. They have problems with the compliance, so we think about the modified Atkins diet, or even finding other alternatives to the diet. They have all sort of hormonal dysregulations we don't really understand, and maybe the change of hormones has to do with them getting more movement disorders, getting the paroxysmal movement disorders, or even getting more seizures than they usually had. So this is a black box, and we need to work on what's happening in puberty. Once they're adults, we thought we haven't got much data on adults, but the concerns, as outlined by Eric yesterday, the long-term effects of the ketogenic diet, of course are our concerns just as well. We worry about bone fractures, we worried about the lipids, we worried about the growth and the renal stones, because these kids and adolescents will take the ketogenic diet much longer than most of the epileptic children will. And then the big issue now is, as these children grow older, how do you bring them into adult neurology? Unfortunately, the adult neurologists are not really interested in GLUT1 deficiency, at least in large parts of Europe, and we have to work on that. I've given a talk on the European meeting of the adult neurologists, and they gave me the prize for the best talk. So I thought, wow, I've made it, and they just forgot about it. Never heard of any of them again. So I was very disappointed, but I think we have to grind that axe further. Let me just introduce you to one of these girls I've been seeing. It's actually a young lady now at Matthew's friend's epilepsy clinic, which I have the privilege to be maybe 3 or 4 times a year. This is Cleo. She's 24 years old, and as you can see here, she has the classical phenotype of GLUT1 deficiency, mild developmental delay, epilepsy at 8 weeks, unresponsive to the drugs, a lot of seizure presentation, movement disorder, paroxysmal events, and for the diagnosis, well, she had the low CSF, she had an impaired uptake, and she had the mutation, so everything fit into place. The only trouble is I met her when she was 21. And that was more a trouble for me than for her, because I was really quite helpless with the problem she presented. She said she has a problem with the ketogenic diet because her symptoms directly relate to the degree of the ketosis. Whenever blood ketosis drops below 2 millimolar, she has seizures, she gets a wobbly, drunken gait, and what's interesting, we had 2 posters up on Thursday evening. She has catamenial epilepsy, meaning that her period affects her seizure control. And really, we had a great time with her, spending with her, trying to work out how to improve the ketogenic diet. Emma was wonderful, and all the dietitians around there, and Arcana. But in the end, we decided we have to propose to give her a PEC tube, sort of a gastral tube for feeding, not nasal, but a PEC tube. And I think she ended up with that because she really depended on the ketogenic diet, and she couldn't take it as a meal. So these are problems I've never faced before, and now we face them because patients grow older. There are actually a lot of adult GLUT1 patients around, and this is a recent article by Lean et al., the Dutch group, and they found that there are 88 adult patients with GLUT1 deficiency described in the literature. And what's interesting is that about a third of them have the classical phenotype, and a third of them have sort of a mixture of the predominantly epileptic phenotype, and another third the predominantly movement phenotype. So it seems to be quite even in adults, but we need to know what's happening in children. What they also described in a different paper was that they looked at the reports of 157 patients with GLUT1 deficiency and how low their CSF glucose was. And if they plotted that, and what you can see here, that we, in adults actually, we have to look at higher values for the hypoglycemia. Otherwise, we might miss these patients. These are the normal, and here is the circles are the GLUT1 deficient patient, and you can see here that really the hypoglycemia is not that pronounced the elder the children become. So that I thought is something interesting to share with you. Coming to the second part of my talk, which is triheptanoin. Triheptanoin is a novel compound we are all very excited about. Why? Because it's a C7 ketoester, and you don't find that in nature. It is an artificial ester. We always have even C numbers, and this is an uneven C number. And this compound has been around in years, and every one of you who's been in Europe or lives in Europe has actually eaten it, because it's used as a trace for butter from the EU. So if you have a piece of butter and you want to know whether it's from Ireland, look for triheptanoin, and it'll tell you it's a fake or it's really from Ireland. Trouble is, it's been used only as traces, so you can't really tell whether it's palatable and whether it has any side effects if you use it as a compound for the ketogenic diet. It's liquid, it's tasteless at room temperature, and what's so special about it? Now, we've seen mitochondrial disease, biochemical. We always come back to the energy metabolism, and as you can see here, the carboxycitric acid cycle produces ATP by a 2C compound called acetylcoenzyme A. Now, if you have fat from the ketogenic diet, it'll be broken down, as you've seen in the previous talk, to even carbons, and as the ketone bodies, it'll enter acetyl coenzyme A and you'll produce energy. Now you could say C7 is just the same, it's just a ketone. No, it's not. What's so special about it is that, yes, part of it will enter the same energy cycle, but the odd carbons will actually take a different path and they can replenish the citric acid cycle, what we call anaplerosis. It's just like refilling a system. And so it has an additional effect. On top of producing energy through the traditional pathway, it can actually refill the energy machine. And that is the novel idea behind it, why it's different to a normal ketone. And it has been tried in mice, and actually we had a very nice poster up on Thursday too, describing that. And there's the first study on 14 patients with GLUT1 deficiency, just came out last month in JAMA Neurology from the group of Professor Pasquale in Texas. He used this compound in 14 patients with GLUT1 deficiency, aged 2 to 24 years, prior to any ketogenic diet treatment. It was an unsponsored, open-label case series study, and it was just used as a regular food supplement with that concentration of oil as a single dose. Now, what was the setup of that study? I'll show you. Patients were tested neuropsychologically before they had an EEG recording. Some of them received an MRI. 15 minutes after the EEG was recorded, they got a single dose of triheptanoin. And then the EEG recording was continued for at least another 1 hour, and then they repeated the neurological testing and the MRI. Then they continued that for another 3 months, and they retested the patient at 3 and 6 months. And here are the results. They found that the spike wave activity in the EEG went down in 70% of patients, except for one. They found that the neuropsychological performance, if you compare these tests, increased, and that the cerebral metabolic rate, as measured by the MRI, actually increased after the ingestion of triheptanoin. Here's the adverse effects. There were none in about 80% of patients. 20 patients had GI symptoms, and 1 discontinued the study. Here's the data on the seizure rate. You can see that before and after triheptanoin, it actually went down in all the patients. And here's the data on the neuropsychological scores. You can see that they used 2 tests, the expressive vocabulary test and a standardized Peabody picture vocabulary test. And you can see they measured the scale at 0 at the beginning, then after 60 minutes and after 3 months. And you can see that except for 1 patient and this one at 3 months, it actually increased. So this is encouraging, and what they concluded from their study was that yes, triheptanoin can favorably influence neural function in GLUT1 deficiency. And this has to do with the anaplerosis I just showed you. Now this is his diagram, that glucose goes in, pyruvate, acetyl coenzyme R, the citric cycle, out comes energy. And here's where the C7 enters, and it's get broken down to C5, and these two go into the energy production, and the odd carbon propionyl coenzyme A enters the citric cycle and replenishes it for more effectivity. I just slipped that in for Gary and all the biochemical experts. This is the glucose lactate shuttle that sort of the glia feeds hungry neurons, not by glucose, that actually the neuron might use the lactate that's produced in the glia, and the lactate actually then will fuel the neuron. But again, you can see that there's a basic mechanism of the tricarboxylic acid cycle in both cells, and it'll produce energy, so this will help in the neuron just as well as in the glial cell. Now, why don't we do studies? If you go and look what are the studies that are reported to a website called Clinical Trials Government in America, you actually find that there are 15 trials done with triheptanoin. And if you break them down, you can see that the majority is aiming on GLUT1 deficiency. 7 of them deal with GLUT1 deficiency, 5 of them with the fatty acid oxidation disorders we just heard in the previous talk. 1 on Huntington disease, 1 on glycogen storage disease, again as we heard in the previous talk, and heart failure in 1 too. So let's focus on the 7 that are dealing with GLUT1 deficiency. You've seen them here highlighted in blue, and you can see that 2 of them are closed. These are the ones from the Dr. Pasquale study I just explained to you with the 14 patients. So if you take them away, that leaves 5 studies that are actually performed on GLUT1 and triheptanoin, and let me just walk you through them. Study number 1 is done in America by Mr. Adrian Lacey. He's at Fort Worth in Texas, and he has a phase 2 study. As all these studies are interventional, non-randomized, and open label, it's planned for 5 years, and it's planned to include 50 patients. They include GLUT1 deficient patients aged 1 to 21 years, and the concept is to allow 35% of the daily caloric intake as triheptanoin, and the rest obviously as a ketogenic diet or as fat. The duration of the C7 is open, so how long are you giving it? It's not really given, and the patients have to be naive to the ketogenic diet. So any GLUT1 patient on the ketogenic diet would not be eligible for this study. The study is actually recruiting right now. There's another study that is done in Canada. It's a very small one, only for 1 year, done by Sylvia Stockler in Vancouver. Only 3 patients planned, 1 to 18 years. It's the same concept. It's limited to 8 months and to patients that are unresponsive to the ketogenic diet. And basically what they are trying to do is find how well triheptanoin is accepted, side effects, effects on metabolism. So it's a bit of a different scope, but still this trial is also recruiting. Next trial is from a firm called Ultragenics in the US, pharmaceutical industry. Phase 2 trial started this year, aims at 40 patients aged 1 to 35 years. 35% of daily calories. You see the concept is the same for 12 months, and I'll just show you the study protocol in a second. Also for patients naive to the ketogenic diet or unresponsive to the ketogenic diet, and this study is recruiting, as is a study in France from Paris, phase 2 study, actually 20 patients still recruiting, even though it was aimed for 1 year. Any patient with GLUT1 deficiency elder than 3 years, and you see the concept is just the same, and triheptanoin will be delivered for 6 months. Now, there's one study that is not really following this pattern. As you can see, all of these 4 studies have a common denominator, which is the firm Ultragenics, which is acting as a collaborator in all 4 studies. In contrast, there's one study that is not yet recruiting, but hopefully it will be, so we have a second set of investigators. And this is, again, spearheaded by Dr. Pasquale, who I just told you about with the 14 patients. In Dallas, Texas, it's a phase 1 and 2 study aimed for 5 years and 50 patients. Any patient 30 months and up to 55 years with GLUT1 deficiency can enter. And he has actually 2 arms. He has patients on a ketogenic diet and naive to the ketogenic diet. The patients without a ketogenic diet will get the triheptanoin at that dosage, and the patient on the ketogenic diet can also enter that study, and they'll just get the same amount of triheptanoin as they would get as a sort of daily fat intake, and this is aimed for 6 months. And this is waiting. This is the study waiting to start. Now, back to the other 4 studies, and just as an example, I'll show you the Ultragenic studies. The way it's designed, I told you it's randomized, double-blind, placebo-controlled. It started in January, and it was aimed until October, but they are still recruiting, so I think it'll go a bit longer. What they do, they have a baseline period where patients are assessed and they don't have any treatment. Then they're randomized into 2 arms for 8 weeks. For 8 weeks, they get the triheptanoin or they get a placebo. And then the study is aimed for 52 weeks. There's an open label extension period where all the patients, also the patient with a placebo, will get the triheptanoin. And then there's the option that if they are happy with it and if they want to continue the study, you can then continue having the Triheptanoin and go on with it. I'll just want to comment on that study, and I want you to understand that this is my personal opinion. I think it is great that we are investigating Triheptanoin, and it's absolutely great that we are investigating it for GLUT1 deficiency. But there are certain concerns about how the studies are being done, and I want to share them with you, and I want to discuss them with you. The first red flag when I read this protocol is that you actually have a treatment that is the first choice, and it's absolutely effective, and that's the ketogenic diet for GLUT1 deficiency. What you do in this study is that you deprive children that are naive to the ketogenic diet of the only effective treatment you have for 6 weeks, plus 8 weeks, plus maybe a whole year. And I think you could debate whether this is the correct approach. Also, we don't know what Triheptanoin is doing. We have a lot of good data saying that it's probably very harmless and you can take it at the amounts the study is proposed, or these studies are proposed for. But the bottom line is we don't know yet. That's why we're doing the studies. So what happens in the worst case if Triheptanoin will not work? The patients will not have the first-line treatment for 1 year, and that might matter in a small child. And the other argument is that Triheptanoin, if it has side effects that we are not aware of, this actually might be a problem in the long run. It's a problem we'll have with all the studies, also the study that Dr. Pasquale is running, and I don't think we have a good way of getting around it, but we have to be aware of where the limitations of the study and the problems are. Also, there's a concern about amongst the parents and the families with GLUT1 that in a company-conducted trial, of course, the aim is to develop a novel drug or to develop a food supplement. And there's a big difference how this Triheptanoin is going to be delivered. If it's a food supplement, it will be much, much cheaper. This is just an assessment published by one of the civil service accountants in the US, and it might be completely wrong that it's about $500 a year as a food supplement, but it'll be much, much more expensive if you use it as a drug, and it has to be described and what happens if the insurances don't cover it or people are not insured, they won't get access to it, and it's going to be a big debate if it's a drug. The second concern for me as a researcher is, of course, I think maybe there's a slight difference between a trial conducted by a university, like Dr. Pasquale is doing, and a trial conducted by a commercial pharmaceutical firm. And there's just the concern that what happens with the data? Will it be fully accessible? If it has unfavorable data, will we all learn about it at the same speed and the same amount like we would learn from independent researchers? And I'm sure, I don't want to talk against the other studies, but I just want to sort of show you the pros and cons and the concerns that are reflected to us as researchers from the families who don't know, shall we enter the study or shan't we do that? We have a responsibility for all these kids, and these are the GLUT1 kids I met in Houston in 2013. And look how many there are, and there are much more. And we are responsible as doctors and researchers to, if we have Triheptanoin, to really set them on the right path and say, okay, this is a trial, you can participate, and I'll support you. And this is something we really need to discuss. And on top of that, we have to find more patients, and we have to understand them better. And for that reason, I strongly encourage you to go to this website. Dr. Pasquale, here he is again in Texas. He has a GLUT1 data bank, and every patient can just go in there and have an online questionnaire and fill in his data. And eventually we hope that with all this data, which will be accessible to all researchers, we can answer how many are there, what's the clinical classification, can we understand the link between classical GLUT1 deficiency and the hemolytic anemia story that we don't understand at all. How about mutations, phenotype, genotype relationships, treatment response, non-responders? What about the long-term effect that Eric addressed? Are there other tissues that are GLUT1 rich affected in these children, maybe when they are adults? What happens in puberty, I told you about? What about the transition into adult neurology? What about the future therapy, including Triheptanoin? So a lot of questions. And I hope that next year, when we meet in Orlando in July, you're welcome to come, then we can provide a few more answers to the questions I just raised. And I apologize that I can just give you a few spotlights, but I hope that you go home with a bit more understanding of what's going on. Thank you.